This light makes you colorblind. Well, only when it's lit. What color is this? Or this? Or this pack of colored pens? You can't tell, right? Comment below your guess of what order these pens are in. Watch till the end to find out what order they are actually in. In this video, I'll discuss color, how our eyes perceive it, and how monochromatic influence our color perception. At the end of the video, I'll demonstrate how you can try this at home. None of the clips in this video has been edited in any way. Now, no matter how strange it might seem, I'm seeing the exact same things with my own eyes as well. This video began one morning as I was playing with my RGB strip lights on my wall, and I realized that my paintings start to change color. I did a bit more experimentation and research to find out what is actually going on, and that led to this video. Alright, enough talking, let's move on to a demo. Look at this piece of paper. The text appears to be black. When it becomes transparent, but still remains visible, then finally disappears. I'll play it one more time. Black, transparent, and gone. Now, when we switch back the white light, we can see indeed that it is a sky blue color. It absorbs most of the red light, making it appear black. However, it reflects most of the blue light, just like paper, making it disappear. This color contains green mixed with blue. Green will disappear under green light, but the blue will absorb the green light, making it darker, giving it unique transparent quality. Now, if you're liking it so far, a like to the video would be enlightening, and a sub would be delightful. Now let's move on. What color is the lid of the glue stick? It's hard to tell, right? Well, it's actually impossible to tell. The glue stick is lit with a monochromatic red light, which means only red is hitting the glue stick and bouncing back into our eyes. Therefore, all we see is different intensities of the same shade of red. This disrupts our color perception since our eyes rely on a mixing of different wavelengths to interpret color. By the way, the lid is actually yellow and the body is actually green. Okay, how do our eyes perceive color anyways? It is an electromagnetic spectrum, and the small section in the middle is what our eyes can detect. Our eyes have three types of cells that roughly sense red, green, and blue. Our brain processes the information from these sensors and, with some mixing magic, gives us a perception of color. Our brain interprets color as a unique ratio of stimulation. So, if you have these two, you see this. If you have these two, you get this. And if all three are stimulated in the correct ratio, you get white. Now perhaps it's time to acknowledge that color is not real, but an experience created by the brain from the information received from these cells. Unless we can stimulate our cone cells in different areas in different ratios, we cannot see color at all. Monochromatic light only contains a single wavelength, so the entire scene will reflect that single wavelength. But color isn't all about wavelength. It is also about comparing those wavelengths to everything else around it. That's how you perceive something as grey, even though it clearly isn't, because our brain corrects for the intense hue of the entire scene. Let's move on to more demonstrations. Look at these felt pens. Yes, indeed, they are the ones from the start of the video in a different order. Note how you cannot tell color at all, as expected. Now, let's gradually add more green while taking red away at the same time. We see a brief transition where there's lots of colors can be differentiated before it plunges back into what it seems like grayscale. The same thing happens when we shift from green to blue. Pay close attention to this red one. It currently appears white because it reflects most of the red light. However, when the color changes, it appears to be black as it absorbs the light. The effect is quite trippy, and the pens look somewhat like a light, switching on and off. As I mentioned in the beginning of the video, I saw my painting start to change color, and here's an example of that. It started off pretty bright, then, like magic, becomes very dark, and then pretty much completely black. Hopefully now you understand what is going on, otherwise you really haven't been paying much attention. The artwork contains lots of red, and as I mentioned before, it reflects lots of the red light but little of the other colors. Watching it change feels like observing a display of sorts. Definitely not a piece of paper. You can try this at home as well. Assume you have some RGB lights, which everyone has at their home these days. According to my findings, red seems to be the best colour because my cheap diodes simply don't produce as clean of a light as compared to red with the other colours. Oh, remember the colour files order I mentioned from the start? Well, here they are. Also, this video acts as an introduction to my upcoming series on light and contains more mind-boggling experiments like this one. So subscribe if you don't want to miss out, as my content easily gets buried within the mountain of content that is out there. Now, there's very few of you that made it this far into the video, and I will thank you very much for watching it. Now, I hope you like it, and goodbye for now.